Hello everyone, MasterZeon1201 here, and in this video we'll be going over some of the changes that have happened in 987_14b, talking about Radial Array. Radial Array has had quite a few things going on with it in the past, and we've sought to expand on it to a degree. However, it became apparent that we needed to do some things involving its relationships with origins and scale in order to truly take it to the next level. So this update log aims to provide more information and background on the context of array and radial array in HardOps and how we deal with it, and also show how we've made some improvements to make life easier for you going forward. So without further ado, let's jump into it. So let's manually set up a radial array. So I'm going to go under modifiers, and first we'll hit it with a displace, and we want to change it to x-axis, so that whenever we displace it, we displace the entire object and not just every piece in every direction. Let's Shift A and we'll add an empty of a sphere, just because I like spheres. And let's select our object and add an array modifier to it as well. And we want to turn off relative offset and turn on object offset and actually pick our empty from the drop down list. I'm going to right click and copy the data path of the count for this particular object. And from here I'm just going to select the empty, right click, and choose to add a driver for the Z rotation. So if you lose the window, you can just right click again and choose to edit driver, which is what I'm doing. And I'm just going to change the result to be count, and we're going to pick the cube, and we actually want a single property where we'll paste in the count that we got for array. And so in this area we're just going to type in radians, open parentheses, 360, close parentheses, slash count, and press enter. And so that's basically it. So now we have our empty and we have our radial array set up. And this means that if we go and adjust our count, we can actually adjust the radial array. And then from there, we could even adjust the strength to bring it in and out if needed. So if you think that that's quite a process, imagine doing it 100,000 times in a row over and over to objects. And so even when it comes to moving the object afterwards, you have to get a little bit considerate with it. So for me, I like to take the empty, parent it to the object itself. So that way I can actually take the object at the end and actually rotate it. We can adjust our scale. We can go in and continue to adjust our array. We can continue to adjust the distance that's occurring between the points, which increases the radius of the radial array. But just like that, that's how you would go in and actually create a manual radial array. So I just want to just kind of demonstrate it as a starting point to just kind of show where radial array comes from and its foundations. So with this radial array that we created, we did adjust the count, we adjusted our scale, we changed some of our parameters based on what we were seeing when we scaled things around, just like we're doing right now. So if we were to go inside HardOps and adjust the array, we see that the array is able to be adjusted modally by our own array system inside the dead zone circle, allowing us to get a greater degree of control. However, let's say we can press Control A and we applied our scale. We see that now we actually have kind of a Fibonacci formation happening with our array because the scale was unapplied. So whenever it comes to solving something like this, it definitely begins to get a little bit more tricky. So scale is also something to be taken into consideration whenever you're dealing with your radial arrays, because, for example, HardOps bevel will generally apply your scale whenever you use it. However, if we press Q and we look at the tooltip, we can actually see that shift clicking will bypass the apply scale portion, allowing you to get in and actually just adjust the bevel of the active mesh without actually applying the scale and triggering that cataclysm that we just saw. But scale is just another one of those things you definitely want to keep in mind with it. Before ending the video, I also wanted to try one other thing where I just added a new cube with Shift A, and we will select this cube, and let's just press Control L and copy the modifiers just to see what happens. And so we copy the modifiers, and we see that this object has now kind of arrayed itself into space very oddly. So even the process of attaching an object to another object's empty to try to get it to perform a radial is going to be a bit of a adventure. So this is also something that, you know, more than likely we'll be revisiting in the future, but just want to just show just how radial array works and how unstable it can be in certain situations and how you can easily just get things to go awry. So in a previous update log, keep in mind we are using HardOps 987.12, so we're about 2 versions behind. We're also using a version of Boxcutter about 2 versions behind. But if I were to press S and Z and scale this and rotate this object, we now have this object at kind of an unusual rotation. And so if I were to say draw a make shape and then press extrude, and we click to apply. If we look at this shape, we see that we have unapplied scale. So because of what I was talking about previously, we know that we want to press Control A and actually apply our scale. And the rotation of this object is fairly simplified in comparison with this object, meaning that when I select both of them and I press Q and go under Mesh Tools, if we shift click Radial Array, we are able to radial array around this object. However, we see that there is an undesirable rotation that occurred. And this rotation is because of differences between this object's origin and this object's origin when it comes to creating a radial array at this location and radiating around it. So more than likely, multiple users have ran into this where they would try to radiate something around something and the object would actually be rotated. And so if we were to lower this to say 4 and take this object, tab into edit mode, we see that we need to rotate this on Z about 90 degrees. We need to press R, Y, Y and rotate it about 90 degrees. And then we're actually back where we started. However, having to do that sort of work when it comes to doing a radial array is just too much. So let's try this operation again. Let's just draw our shape. Let's just press A, and we'll press E to just extrude it out just a little bit. And so one of the solutions I wanted to try is having users be able to press Q, go under Mesh Tools, go under Set Origin, and just click and drag to create an origin, which will basically give this object the correct origin needed to radiate around this object. However, having to go into set origin prior to going into radial array is something that's going to be a little bit of a nuance. And also, what about that scale issue? That scale issue was something that was a little out of control, right? So let's take both of these objects and delete them. And let's talk about radiating around the 3D cursor. So, we'll just grab the corner of this box and press Ctrl-Shift-B to bevel it. And let's just place our 3D cursor here, and let's just perform a cut. So we want our cut to rotate around this 3D cursor. Because this object is rotated in a way that's actually aligned with the plane that it was drawn on, that means that if I go under radial array and actually click radial array, everything works out correctly, right? However, this is no basis of stability for us to be able to work, because in the event that our shape was not actually congruent with the surface that we were radiating around when we were using the 3D cursor, it wouldn't have worked out. And so to show that in action, we're just going to select the object, maybe press Shift V and go into nearest edge orientation so we can orient it to this area. And this shape is definitely not oriented to this particular surface, but we want it to radiate in the 360 method around the surface. So if we select this and we shift click radial array, we see that that's not actually possible. And so this is kind of where this journey ends. And then even to make it worse, this object up here has been rotated and is no longer even the object that we knew and loved it as. So let's try using the same solution that we did using set origin. So at first the idea was that, hey, you should be able to just go into set origin, click and drag a line to basically create what you need, basically giving you the orientation that's desired. And then when you control click radial array, you'll be able to get what you want. However, we see that we didn't actually get the most desired result. And that's because the origin that we want to base this off of isn't actually available to us. And that's because we need to disable some of our booleans. So that way we can select the shape, go under set origin. We can press S in order to see the dots for shapes that are not selected. And we just drag a dot to here, let go. And now this object's actually oriented in a way that will be advantageous to the 3D cursor. And to prove that, I'll just control click radial array, and we see that we're now able to radiate this object around. However, like I said, this is no basis to work. We need something a little bit more stable, a little bit more predictable for users to be able to perform rapid radial arrays without issues and having to deal with their offsets being off and things getting weird. So I just wanted to show kind of just some of the shortcomings of the previous system and how it would fail. Because while I was able to solve it this time, having to scroll back in time in order to grab a pure origin is just lunacy. So there are some things that we did to attempt to mitigate that process, but just to show it again, we'll cut another box, and if we control click radial array, we are radiating around the cursor, but we're not oriented to the surface that we're dealing with. And if we look at our 3D cursor, it's not oriented very well to the surface either. So it's really not a basis for us to play off of. The only thing we can do is really just go back in time to the point that we have the origin desired, and then go under set origin and actually set it to this, and then turn on all the meshes. And from here we can just control click radial array, and we can just array just like we intended. However, we see that it's a little bit imperfect in some places, but we're not aiming for completion with this model. We're aiming to show where radial array falls short in this particular iteration. So here I am back in the classic HardOps using the classic radial array as you all knew it. And we'll just press S and Z, and little do you know, I just made a serious mistake. With unapplied scale on this object, that means when I press Q and I go in and add a radial array, this object will be radial arrayed with the scale kept, but the empty will also be scaled in order to compensate. And the good news about this is that I can go back in and adjust the radial array just on the fly and change the count to whatever I need it to be, and nothing will be a problem. However, if we were to say select this mesh and add a bevel, we see that there very much seriously is a problem. And that's because the scale's been applied on the object, but the empty has unapplied scale. So if we were to just select the empty and just change the scale to 1, we see that we're back in business. And so this is good and all for whenever you're working in stationary states, or linearity as I call it, whenever you're working with flat X, Y, and Z. But if we were to say delete these objects and begin working at an angle, let's just SZZ with this at a rotated angle, and from here just choose to perform a radial array, and we also were to choose to apply our scale, we see that things get out of control. And if we select our empty, we see that all we have to do is just change this to be 1 and things are back in control. However, because of our transformation that we've given it, we're actually getting an undesirable result, unless you desire getting a result like this. But this sort of thing is one of the problems that really drove me crazy with Array, was that the amount of things that were happening to it beforehand were just unsatisfactory. I mean, in all honesty, basically, if you have your mesh scale and you jump into radial array, I am of the opinion that the object should have its scale applied on the way in. Another thing is, let's take this object and move it away from the origin, and let's press Ctrl A, and we've applied our location. So our location is now here. If I were to press Q and go into radial array, where do you think this radial array is going to begin? If you think it's going to begin where the cursor is, you're absolutely wrong. For some reason, radial array would recalculate the origin based on the location of the actual object, which was also problematic. If we press H, we can see that the option of C will allow us to radiate around the 3D cursor, which is a kind of a band-aid for the situation. But really, this is just part of the long list of issues that was kind of building with radial array and needed to be dealt with. So another situation I just want to show is, let's just take this cube corner and we're just going to Ctrl-Shift-B bevel it and jump over into Boxcutter, enable dots, and we're just going to slice this area out and press X in order to turn it into a slice, and pressing Q, set origin. We're just going to set our origin to this location. And I just want to show the conundrum that I'm specifically trying to solve, and that is being able to cut a piece out like so, be able to recall that piece, and actually radiate it around the piece at hand. So in order to do it with this piece, we should be able to select this object, and just by shift clicking radial array, we should be able to radiate around this surface. In fact, let's press A to turn off displacement, and let's just roll the wheel to lower our segments, and we see that we were able to get that desired result. So everything is so far so good. But what if we were to, say, draw a circle here and mirror it to the other side, because we've given this object localized symmetry, and we decided that we wanted to shift click to radiate around this? Well, once again, I have to press A to turn off displacement, or D in this case, but really it's a question of, where the heck did my object go? It's not even where did my object go. I said my object had its rotation reset, and we're not going to be able to work this way. I can't work this way. This is freaking insanity, is what I would be saying if we hadn't solved this issue. But with this selected, I'm just going to go under set origin with just that selected, and we'll press S to look at everything that isn't this object, and we'll do something like that. And let's try it again. If we press A to turn off our displacement, we can see that we're nowhere near the desired result. So it definitely can get really hairy whenever it comes to the radial array of your. So a radial array and a drunk man walk into a bar, right? And you take your object and you scale it up without applying your scale, and you go under mesh tools in the Q menu, you activate radial array, and voila, we see that our scale is applied on the way in. it's important that your radial array has its scale applied so the empty doesn't come out all deformed. So that's one of the things first and foremost that I tried to have dealt with this particular array, meaning that if we were to press Q and we add a bevel and we go in and start adding a bevel to this, everything's going to be just peachy. And even better is if we were to just scale this object down on the Z to something even smaller and less satisfactory, deforming even our empty, we could press Q, go under mesh tools and adjust our radial array either through the radial array, and we see that nothing gets disturbed. But we can also adjust it under our array and nothing will also get disturbed, of course, while you're inside the dead zone circle. But just like that, we now have radial array able to work better with applied and unapplied scale, at least behaviorally, on the entry and re-entry of such a system. We could press Alt S and reset it, and that's just one of the first things we wanted to deal with, was eliminating scale related issues and just letting you know that this is one of the things that's avoided on entry but bypassed on re-entry, so it should resolve in a much more fluid radial array experience. So the next example I want to talk about is the shift to radial improvement. So if we take this cube and we press S and Z and we scale it up, we can rotate it sideways, right? Looking at it from a very weird angle, let's just begin drawing a box. We'll press A and that's our box, right? Let's select this, select our object, shift click radial array. Now we're able to drop this exactly where we need it without any sort of weird rotation occurring. Let's draw another box. This one's oriented on the front this time. Let's shift select both objects, shift click radial array. We see it uses the same settings as before. Let's draw another box. We'll press A, but during extrusion we'll press W so it's a wedge. We'll select both the shapes. Let's press Q and shift click, and we see that whenever we do that, that under the shift radial, we now will give the object that you're intending to radial around the other object the same orientation and rotation as the object that you're dealing with. So that way, both of them will radiate perfectly. So the next thing is we just want to draw a shape. We'll leave it as this, but let's just choose circle, then select box in order to reset. And let's just shift select both of them. Shift click radial array, we're able to radial array that. Let's select this object, go under circle, we'll just draw a circle. And that will be our cylinder. Let's mirror that to the other side of this object self. In fact, this object's kind of ugly. Let's mirror it across itself too. But we also want to make sure that the mirror modifier that's doing that is all the way at the top, so that way it propagates to all the sides. But maybe post boolean so that way both sides look exactly the same. So with this object, even though it has all this business going on, because it's based off of this object somewhat roughly, that means when I select both of these and I control click radial array, we will, or actually when I shift click radial array, see how it goes haywire when I select the wrong option, we're able to radiate this object around this as well. So just showing the degree of improvement that's been had with radial array and what it was doing before. So hopefully I was able to show previously how just terrible it is to have your object just automatically rotated whenever you're trying to radial array it. So I believe that was a misinterpretation of a previous request, but I felt that the set origin adventure that we were going on was actually going to solve a lot of the origin related issues. And so radial array is one of the first visits on the tour of kind of re-origining hops to get things on track. So let's press Q, shift click radial array, and we see that we're able to radial array this quite easily. Because of sorting, we can just perform a boolean and that will propagate to every side. Actually, I don't know if that went to any side. Let's try that again. Which one's the real one? This one? We perform our cut, and now we see that went all the way around. So I'm not sure what happened there a moment ago. Let's press Alt VE just to get a better looking viewport. And from here, we're just going to draw a shape based on this side. So we're not even drawing on the same side that we've been playing with. But I'm going to select this object, shift click radial array, and we see that this object too was able to radiate around the intended area the way that we intended. So I've just been doing this all day as like a sort of tool test to just make sure that this is damn perfect. And so hopefully everyone enjoys this latest iteration of radial array. So previously I had shown that if I were to take this cube and move it on the Y and press Ctrl A and apply to location and go under cube mesh tools and use a radial array, it'll actually start from where the object's located, which is actually undesirable. So this is something that was resolved this version. So if we minimize this, if we were to drag this cube out on the Y, press Ctrl A and apply to location, but we were to go under mesh tools, radial array, we see that we're able to radial array using our object's origin kept exactly where we had it. And of course with movement we're able to adjust it if we're dealing with something linear, but just keep in mind that this was something that was resolved for this update. And to give some context as to what preserving the initial orientation origin means in terms of radial array now, is that if we were to just begin cutting on this box using static grid, I'm just going to cut out a corner, and from here actually take this in edit mode, just bevel these 3 edges, and then from here just jump off this center point, press period, and we'll just take this entire area off. We'll use set origin to specify our origin as being of this area, meaning that whenever we draw a box and we press I and we were to shift it to live, if we were to select this and then select this piece, we could actually go under set origin and shift click to take the origin of this mesh and give it to our main mesh. So basically it'll make anything in your selection share the origin with the last thing you have selected. And what this means is that now that we have the specific origin set, we go into radial array, roll the wheel a couple of times, and now we are quickly able to just set up this easy radial array. And so we could take this even a step further. We can just draw a circle, extrude it down, shift to live, select both of these surfaces. Instead of going inside of set origin, we can just shift click set origin in order to give the origin to the secondary object. And if we were to just click on radial array without even holding control, just like that, we're able to radiate this shape around this particular formation based on the particular origin that we have locked into place. So this is a kind of more practical example showing why we pursued such a route. I'm going to press Shift V and change this to local. See what I'm able to get with my cutter that way. Shift this to live, Alt X, mirrored across itself. We could take this and select this object and just shift click set origin to just share the same origin as this object. We can't go back in time to grab this. We could, but I would just prefer not to. And from here we just click on radial array and we see that it uses the same settings as before, and just like that we're able to radiate these objects around, which is something we just were not able to do in the previous version. In fact, to try that, I'm going to copy these objects to clipboard, and we'll jump into previous version of Blender, delete the object, paste everything. Let's just control click manage to just get rid of everything that isn't a, there we go, control click manage in order to evict everything, and let's try it in the previous version. So we're just going to cut a simple circle and we'll select both of these objects, and let's just shift click radial array, and we see that we're able to radial array around this particular object because our origin is actually flat with the particular plane that we're radiating around. But let's try it in the context that we were just demonstrating. So now this one's definitely not oriented to this particular plane. If we go under radial array and we shift click it, we see that this object's just lost. We can come out and look at it and we see that the object's been retransformed in order to attempt to fit this particular radial array, but that isn't the outcome that we were going after. So if we look at this from top view, I'm just going to shift right click to place my cursor there, and we're just going to move the object here. And basically I want to show that if we go under mesh tools and we activate radial array, we see that it radiates based on the object origin. However, if we were to press Ctrl A and apply its location and we go into radial array, we see that we radiate based on the origin that we have specified. But if we press H, we see that with the C key, we can actually start from a calculation of the object, where we can press D to unlock the displacement. We could press C to actually radiate around the 3D cursor, where we could press D to unlock the displacement. But just like that, you're able to change your location of radiation on the fly just by pressing the C key. So just in case you still are having issues with setting your origin center whenever you're inside of radial array, that's precisely what the C key is for. So just by pressing it, we see that we're able to jump between 3D cursor, the initial object origin that was set up before we even began this operation, and the object center that's been calculated as a result of us calculating the bounds of the object, which will give us the most predictable result whenever it comes to radial array. Of course, keep in mind that pressing X will allow you to change your axis, so you can get your axis on the fly. You can press C to change your origin type and still change your array on the fly in order to find the particular axis that you're going for. So for some of these, I'm just pressing C just to jump between them, just to show you what they look like. On the Y axis, we can still press X to toggle between the axes, and we can do this while still changing our origin center on the fly. So whenever you select your mesh and you press Q and you go under mesh tools and choose radial array, you also have the ability to press R in order to set your rotation to a lesser amount. For example, now my rotation is set to 90, 60, 45, 30, 360. But let's say you want something actually in between this. Well, you're now able to hold shift and roll the wheel in order to manually adjust the amount of rotation that you're giving in between your radial arrays. So in the event that you're going for a partial rotation or 1/4, you can actually get that set up quite easily and customize your beginning and end point quite easily just by shift scrolling whenever it comes to dealing with radial arrays. So that functionality has been improved as well. In closing, I just want to say that I hope users are able to get into and enjoy some of the improvements that have been had with this radial array. Like I said, our work into the set origin dimension is what actually has enabled radial array to improve to this level, and I see some other places in the workflow where origin control can improve things with our ability to get things exactly where we want to. And this is just a foundation before we begin getting into advanced placement services for objects. So I hope users are able to keep up with all the stuff that's going on with radial array and set origin, because we do try to keep these things fairly simple. However, a large degree of work does go into ensuring that the user gets the proper result whenever they use our tools, even if that means that we have to apply scale for you or deal with situations that are normally things that are gotchas that the user should actually deal with in advance. So with that, I'll wrap this video up, and I'll thank you for watching, and I'll see you guys next time.